expands slowly. That means it, like, the gas particles moves further apart, but the temperature remains constant. Like no change in temperature. Okay. So basically they're not moving fast. Oh, one more thing, that speed of particle is directly proportional to the temperature. As temperature increases, I mean, as speed of particle increases, as they move faster, temperature increases. But as the particles move farther away from each other, okay, that is when the gas expands, increases in size. So basically they move farther apart and average speed remains unchanged. Temperature remains constant, so average speed remains constant. So that is C. Next comes air in each of the four syringes compress slowly. Okay, volume before and after compression, and we know this law, gas law. P1 V1 equals to P2 V2, the pressure volume thing. Okay, all four syringes is at the same pressure, so initial P1 is same for all, right? Initial P1 is same for all. Volume, volume before, volume after, and this is the final pressure. Okay, in that sense we need to find the pressure 2 for each of them. So using this formula I've already calculated. P1 is a constant, so I'm removing that. So P2 equals to V1 by V2. Okay, so basically, okay, so this is the thing. So volume before compression, while using it I have found that P2 is 5 for this, 2 for this, 4 for this, 4 for this. So which is the least? The least is B, this 2. This is the least. So the answer is B. The temperature of substance is measured glass liquid thermometer. As we know, the thermometric property for a glass and liquid thermometer is definitely volume of the liquid. Boiling, evaporation are different. Boiling occurs throughout and evaporation occurs at the surface. So which is correct? Boiling occurs only at the surface? Nope. Evaporation only occurs when temperature is high. Evaporation does not depend on temperature that way. Boiling does. Evaporation does not change. No, it does. As you know, if when we are sweating, as water evaporates from our body, we feel colder, right? So yeah, it decreases the overall temperature of the liquid. And boiling liquid heated up to its temperature, yeah, because of state change, when boiling liquid is heated up, its temperature remains constant. We can see this heating curve. So here temperature constant, that means state change. Okay, so it's D. Okay, so a glass beaker, this is convection current. So what happens in convection current? Hot air rises, cold air sinks, or hot water rises, hot water sinks. So basically it's fluid. Water and gases are known as fluids. So hot fluid rises, cold fluid sinks. So water above rises, it becomes less dense and sinks to the bottom. So the answer is C, just as the definition. A hot meal is supplied in a container made of shiny metal foil. Oh, reflector. So why does the container help to keep the food hot? Like food wrapped in aluminum foil. Good. Why? It's just container traps air? No, it's nothing about air. Foil is a poor thermal conductor. Who told you? Foil conducts heat very well. Shiny metal foil, good absorber. Well, it's the opposite. It's not absorber, it's reflector. So shiny metal foil is in the inside of it, inside part. So as the so this is, say, a meat, a chicken fry something. It's surrounded by this metal foil. When heat tries to escape, this metal foil reflects the heat back, so it keeps it warm in this way. Okay, so it's D. Well, which quantity defined as the number of wavelength passing per second? So that is definitely frequency. That's the definition of frequency, number of waves passing through a point. So plane mirror Plane mirror, you know, those mirror that you look at yourself in every day, same mirror. It's the object in the mirror is of the same size, definitely it's basically you, and it's virtual image, you cannot project that image, okay? And any image that can be projected is real image, but this cannot be projected, this is virtual, you cannot touch it basically, okay? You cannot touch it, you cannot feel it, so it's virtual. So B. Ray of light strikes at angle of incidence 45. Refractive index this. What is the angle of refraction inside the block? So Snell's law, look. Sine incidence angle divided by sine of refracted angle equals to the refractive index. This is the formula. So basically sine 45 divided by sine the angle equals to 1.8. So basically what you need to do is reverse it. Sine 45 divided by 1.8 equals to okay, this equals to sine r. So if you want to find r equals to sine inverse this sine 45 over 1.8, that gives me 23.13. So yeah, A is the answer. That's it. Why did I give a question mark? Okay, so look at this question. A, definitely diverging lens. B, whatever, I'm coming to that later. C, look at C, it's basically A, the same image, look at the image, it's basically the same. When we are moving the lights from this position, I mean the light rays from this to that position, okay? So what a converging lens does, I mean what a diverging lens does, it does something like this, but those two never meet. So basically it's the same lens, it's a diverging lens. This is the diverging lens, of course, like all three same, okay? So B is basically the converging lens. It converges the light ray towards the normal. This is the normal, converges it towards the normal. Okay, that's it. If I tell you in another way, see this thing. This is the incident ray, right? This is the incident ray. So this is the normal. Wait, normal, my bad. Perpendicular to the surface, my bad. I cannot draw it straight, man. Whatever, just consider this as a normal. Okay, this is a normal, good normal. Okay, this ray seems to be moving away from the normal, diverging. This ray seems to be moving towards the normal, converging. This ray moving away from the normal, diverging. This ray again moving away from the normal, diverging. So this is the only thing that is converging. Okay, we have to compare the angles. So yeah, it's B. A beam of light strikes. It's basically the Newton um, light splitting experiment. Okay, all lights travel at the same speed. No, if all light traveled at the same speed, so the light should have like boom boom, should have gone in, should have come out straight away. Not this. Light has a lower frequency. Exactly, X has a lower frequency, that's why it's on the upper edge, right? And Y is on the lower edge. V equals to F lambda, remember the formula. Refracts more, well no, it refracts less. White refracts away from the normal. White light has broken, man. So D. Okay, so this is easy. TV remote control, we all know it's infrared. The small bulbs, the small white bulbs at the tip of your remote control, the white bulbs, those are infrared emitters. So it's TV, it's infrared. From Earth to satellites, it's definitely not ultraviolet, it's microwave. We don't use ultraviolet, it's the wave that comes, I mean the sun's harmful rays, it comes to Earth. That's the ultraviolet ray, the UV ray. I mean we use it to disinfect stuffs, but not to send a signal from Earth to satellite. We use microwaves. Okay, Okay, this is okay, sort of a trick. Anyways, you see, you have to understand. First he claps, clap one, then the sound goes one, returns two, then he claps again. Okay, so within this two clap, I mean first and second clap, the sound moves twice, right? So 11th clap. So the 11th clap must be when it travels right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 finally. So 10. So that means it travels 10 times. So it travels this distance, I mean 10x. It travels 10x in 9.4 seconds. Okay. It travels 10x in 9.4 seconds. So we have to use the simple formula S equals to d by t. S is 320 equals to d is 10x divided by 9.4. Let x be the single distance. Well, it's written though. So x equals to 320 times 9.4 divided by 10. That gives me, well, for my calculator, 10. This gives me 308. Okay, 308. We have to half it because each revolution, I mean, between each clap, it moves twice. So we have to half it. So that is divided by 2. That is 150. So understand the fact. First clap goes on, goes back. So how many times? 2 times. It moves the distance 2 times. So on the 11 clap, it moves 10 times. So 10 times means 1, 2. It like 10 times, like 10 times 10. Well, it moves forward and backward 10 times. That means the total distance covered is like 20 times basically. Means it's twice. It moves twice, between 2 claps. So that's why I've divided by 2. That's it. Okay, next comes compass. It's easy. It's basically a compass, and we all know the compass has a permanent magnet. A compass, yeah, nil is definitely a permanent magnet, obviously. And a permanent magnet brought next to another magnet. So this is the north pole for sure. We know with the arrow. So if this is the north pole, it should move corresponding to the south pole of this bar magnet, right? North pole corresponds to south pole. I mean, north pole is attracted by south pole, and the south pole attracted by north pole. As simple as that. C is the answer. X is the north pole, obviously. The south pole points towards the north pole of the magnet, right? That is how it works. This is electrostatics. When plastic and wool are rubbed together, basically the plastic gains electron, it becomes negatively charged, and the wool loses electron. The wool loses the electron, and those electrons are gained by the plastic. Okay, so the plastic is negatively charged, yeah, definitely, because it attracts your hair. Remember, if you rub it with a plastic and move it towards your hair or a tap, like the water flow bends, it's because it is negatively charged. Okay, the electrons in the water, like, they're repelled, so the positive charges are being attracted with the extra electrons. Okay, final charge on plastic gains electron means negative, final charge on wool loses electron means positive. So yeah, B. Okay, this is the one. We have to know the circuit symbols here. So this symbol corresponds a heater, this is a fuse. This wire, it melts and the circuit breaks. This is a fuse, this is a fuse. So heater and a fuse, B. Simple. Okay, this is an LDR used for an intruder alarm. So in this case, when intruder comes in front of the alarm, a light bulb is turned on. So how does it work? When an intruder comes, okay, in front of the LDR, so no light falls on the LDR, okay, so its resistance increases. So here, when resistance increases, so the current flows. Say if resistance is in A, resistance increases. What happened to my tongue? Haven't had my dinner yet. Well, if the resistance increases, so basically the circuit stops. Like the electron cannot move, right? So A is closed. No lamp is lit up. So nope, this is a false alarm. Well, I mean not a false alarm. This alarm won't work. In case of C, high resistance, electrons won't reach the light won't turn on. In this case, the same. But in B, if resistance of LDR increases, electrons will flow through the light and then through the resistor to the battery, and the light is lit up. So basically, when there is no barrier in front of the LDR is receiving proper light. This is having a low resistance. Electrons are flowing through the LDR, not through the lamp, because lamp has a bit of resistance, but the LDR has a lower resistance when light is shown on the LDR. Okay, that's why. I mean, LDR having low resistance than lamp in normal circumstance, so electrons prefer the path of least resistance, so it flows through this path. Okay, and when a barrier comes and prevents light from entering LDR, its resistance increases, right? So as its resistance increases, it becomes higher than of the light. So light is a easier path for the electrons to follow through. The electron flows through the light and completes the circuit, thus lighting up the light. Simple as that. And fixed resistor is less than of the lamp. That means it won't cause any difficulty for the lamp to light up. Simple. So B is the answer. Okay, this math is simply solved by the formula E equals to VIT. Basically, it's E equals to power into time. So as we know, power equals to VI, so E equals to VIT. So using that formula, V into I into T, that gives me 120. VTI. That done. Simple as that. Next comes a generator. AC coil generator seems to be. These are, yeah, slip rings, obviously, not split rings. Split rings are split like that. So these are not split rings. These are slip rings, obviously. And if this is north pole, this has to be a south pole. Otherwise, if this is a north pole, the coil would be stuck, right? So this has to be a south pole. North pole repulsion, south pole attraction, it moves. Then again, south pole repulsion, north pole attraction, moves again. So it keeps moving. So it's south pole. North pole, it should get stuck in a certain position, right? So it won't work like that. Loudspeaker, again, an electromagnet. So first of all, this sign means AC current. So direct current, hell no. The current in the coil produces a changing magnetic field. I mean, when the electrons are changing its direction in an AC current, okay, in an AC current, an alternating magnetic field is produced. So yeah, changing magnetic field is produced. A force is produced. Definitely a changing magnetic field causes a force, because this thing becomes a magnet itself. So it changes its pole. So this side becomes north, this side becomes south. Again, when the electron switches its position, this side becomes south, this side becomes north. So push and pull, push and pull, push and pull, attraction, repulsion. So a force is produced. It does not spin. The coil does not spin, man. It never spins like that. Why should the coil spin? It should just move backward and forward, attract it. I mean, look, let me make you understand. This is a coil, right? When electricity passes through it, when AC current passes through it, okay, AC current. When AC current passes through it, this becomes a magnet itself. This becomes a temporary magnet. So this side becomes north pole once, and when the current changes its direction, this side becomes south pole, this side becomes north pole. This keeps switching. Okay, this is south pole, right? So this is the south pole of the permanent magnet in the speaker. Okay, so this is the south pole. When this becomes north pole, it is attracted. Then when the current changes its side, okay, it reverses its direction. This becomes south, this becomes north. So then south pole repulsion. So it moves forward and backward, forwards and backwards multiple times due to the AC current. If there was a DC current, so DC current, so it moves in a single direction. Okay, so this north pole, this south pole would have been a fixed position for this. So this should only move in this direction. But in case of AC current, this magnetic field changes. That means the north pole and south pole switches its places. So it's C, 2 and 3. Okay, it's the step up, step down transformer actually. Simple formula, NS by NP, VS by BP, directly stated in the book. So using that formula, this is secondary, number of turns in secondary, number of turns in primary, voltage in secondary, voltage in primary. There we have the top one is number of turns in secondary, I don't know, number of turns in primary, it's 600. Voltage in secondary, it's 12. Voltage in primary is 240. So that gives me 30. Number of turns in secondary, NS, is 30. So that's B. Alpha particle. Oh, Rutherford. Ernest Rutherford's experiment. That shows. Oh, look, plot twist. Not a conclusion. Which is not a conclusion. Surrounded by mostly empty space. Yeah, he concluded that. They're very small. Yeah, nucleus is very small. He concluded that as well. Contain most of the masses. Yes, but that is not relevant. Okay, that is true. They contain proton and neutron. Oh, that thing was not like you know proven by the um, alpha particle deflection. Okay, that thing was not proven. They contain proton and neutron. Okay, so this is not a conclusion that they contain proton. They did not know that time. Okay, they knew that they have a nucleus, something inside. It deflects. It was small, and most of the space is empty space. That's it. Nothing about proton and neutron. That's it. Radioactive source. Simple. Thick sheet of lead. What does it do? It prevents the radiation from reaching the detector. So count rate would decrease. Strong magnetic field. Nah. This is a gamma ray, so nothing would happen in case with a magnetic field. Okay, this is not any electrons, not a beta ray, not no alpha ray. So basically it's beta ray would have been moved to one side, but not this, not gamma ray. Gamma ray does not have any charge, no polarity. So B crossed out. C, move closer. If we move closer to the detector, more particles, I mean more rays enters the detector, so count rate increases, like more counts per second, so count rate increases. Detector moved further away, so count rate would decrease. Nope. So it's C. Nuclear fusion. Fusion, the word fusion means moving together or staying together or mixing two things together, joining of two nuclei making a larger nucleus. That's it, as simple as that. Let's proceed. Statement, orbital speed. In A levels you would know orbital speed is this. We don't need to think about this. It's 2 pi average diameter, whatever. Moon. Okay, let's look at C. Moon takes approximately 1 month. Nope, 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 nope. Across the sun. Like the moon does not even orbit the sun, it orbits the earth. Okay, it moves around the sun though. Indirectly, yeah, it does, but not definitely not 1 month. Light takes 8 minutes, not 5. Check it out. Orbital speed of the sun. We know nothing about the orbital speed. Orbital speed is this. Gravity, universal gravitational constant. Larger mass divided by this radius, root over. Nothing like this. An orbit of Earth is an ellipse. Yeah, it's an elliptical part. Like just Earth moves around the sun, not in a circular path, but in an elliptical path. So that also is responsible for weathers. Further away from the sun, further away from the sun, that means winter, like more less heat, more cold on earth, so winter time. And closer to the sun, that means summertime. Summertime, yay, summertime is holidays, right? Okay, so that's it for today. We are done. Thank you so much.